Atoms, basic unit of matter, don't like to stay isolated in nature. Atoms want to be stable, and to attain stability, atoms always aim to combine with other atoms and to reshuffle their valence electronic configuration. Atoms of some elements like to donate their valence electron to the participating atom. But atoms of some other elements only like to share electron. In this process, atoms are bound together, forming the molecule of a new compound. The bond between two atoms is called the chemical bond. The chemical bond is the strong force of attraction which binds two ions or two atoms as a single stable unit. The chemical bond is of three types: the ionic bond, the covalent bond, and the coordinate bond. But before discussing each of the bond type, let's have a look at the periodic table. The alkali and alkaline earth metals, which lie in the first and second group of the periodic table, with 1 and 2 valence electrons, they are highly electropositive, means they need less energy to discard their valence electron to form a cation. So atoms of these elements donate electron to form an ionic bond. The transition elements are metallic in nature and have variable valences, but they are also electropositive. For this reason, atoms of these elements prefer to donate electron to make ionic bonding. The metalloids with higher valency generally like to share electron for a covalent bonding, but sometimes at some special context they make ionic bonding with the metallic elements. The nonmetals and halogens have high ionization potential and higher electron affinity. For this reason, they never discard electron but can accept electron readily and form an anion. For this reason, they either accept electron or share electron when they make a bond. When a metallic atom combines with a nonmetallic atom, the bond they form in between them is called the ionic or electrovalent bond. A metallic atom has low ionization potential and lower electronegativity. For this reason, metallic atoms can readily discard their valence electron. On the other hand, nonmetallic atoms have high ionization potential and higher electron affinity. For this reason, a nonmetallic atom can readily accept electron. So when a metallic atom discard and donate its valence electron, a nonmetallic atom readily accepts that. And as there is a complete transfer of charges taking place, both the atoms get ionized. The metallic atom becomes a positively charged cations and the nonmetallic atoms becomes an anion. And for being oppositely charged ions, both the ions face the strong electrostatic force of attraction in between them. And this strong electrostatic force of attraction binds the two ions together, forming the molecule of a new compound. So the bond, the strong electrostatic force of attraction, which binds the two oppositely charged ions, is called the ionic or electrovalent bond. And the compound that they form is called the ionic or electrovalent compound. Let's see the conditions that need to be fulfilled for an ionic bonding. The metallic atoms should have low ionization potential to form cations readily, and the high electron affinity leads the non-metallic atoms to form anions easily. And there should be a large electronegativity difference between the metallic and non-metallic atoms to enhance the transfer of electrons. Let's see some examples of ionic bonding. An aluminum atom has 3 valence electrons, but an oxygen atom can accept only 2 electrons. Therefore, when 2 aluminum atoms combine with 3 oxygen atoms to form the compound of aluminum oxide, the 2 aluminum atoms will donate their 3 valence electrons, and the donated electrons will be equally distributed among the 3 oxygen atoms. Both the aluminum and oxygen atoms get oppositely charged ions and combine together, forming the molecule of aluminum oxide. When metallic sodium discards its lone valence electron in favor of nonmetal bromine, the bromine readily accepts that and becomes an anion. The sodium cation and the bromine anion combine together, forming the molecule of sodium bromide. Highly reactive potassium. When combined with iodine, the potassium atom discards its lone valence electron in favor of iodine. The iodine atom accepts the electron. Both the atoms gets ionized, oppositely charged ions, and they combine together, forming the molecule of potassium iodide. The properties of electrovalent compounds. Generally, the electrovalent or ionic compounds are hard crystalline solids because they are formed by oppositely charged ions. They have high melting and boiling points, and they can conduct heat and electricity because of the presence of ions. The ionic compounds are generally soluble in water, and on passage of electric current in aqueous and molten state, it dissociates in constituent ions. The ionic compounds are volatile in nature. When two nonmetallic atoms combine with one another, they do not go for transfer of electron because the nonmetallic atoms have high ionization potential and higher electron affinity. For this reason, they never discard electron. So when a nonmetallic atom combines with another nonmetallic atom, they simply go for sharing of electrons. The nonmetallic atoms overlap their valence shell and contribute equal number of electrons, making electron pair. The electron pairs are shared mutually by both the nuclei. It is the molecular force of attraction between the shared pair of electrons and both the nuclei which binds the two atoms together, forming the molecule of a new compound. The bond, which is formed by mutual sharing of electrons, is called the covalent bond, and the compound that is formed by this kind of bonding is called the covalent compound. Let's see the conditions that need to be fulfilled for covalent bonding. It is a bond between two non-metallic atoms. The participating atom should have sufficiently low difference in electronegativity, and the combining atoms should have high ionization potential. Some examples of covalent compounds are the formation of fluorine molecule. Two fluorine atoms contribute their single valence electron, make an electron pair, and share them mutually. and they form the fluorine molecule. As only one pair of electron makes the bond, it is a single covalent bond. The oxygen atom has valency too. So when two oxygen atoms combine with each other, they contribute their two valence electron and make two bond pair, which is called a double covalent bond. When there is two or more bond pair, that type of bond is called unsaturated because any of the bond can be opened to make a new bond combination. The nitrogen atom has valency 3. So two nitrogen atoms will make three bond pair to form a nitrogen molecule. The bond with three bond pair is called triple covalent bond. It is also unsaturated because any of the two bond pair can be opened to make a new bond combination. In the molecule of ethane, we find two types of bonding. There is a double covalent bond between two carbon atoms, and the two carbon atoms make two single covalent bonds with two hydrogen atoms. So the molecule of methane contains the single and double two type of bonds. But covalent compounds are of two types, polar and non-polar. In polar covalent bonds, the shared pair of electrons are not evenly distributed among the participating atoms. In a water molecule, the oxygen atom makes two single bond with two hydrogen atoms. But the oxygen is more electronegative than the hydrogen atoms. For this reason, for being more electronegative, the oxygen atoms draws the shared pair of electrons more towards itself. As a result, the shared pair of electrons shifted a little more towards the oxygen electron cloud. For this reason, the oxygen atom gains a slight negative charge on it. On the other hand, as the shared pair of electrons are shifted a little far from the electron clouds of the hydrogen, for this reason, the hydrogen atoms attain a slight positive charge, and the molecule of the water becomes a polar covalent molecule. Same happens when the chlorine atom makes a bond with the hydrogen atom. For being more electronegative, the chlorine atom draws the shared pair of electrons more towards its own electron cloud, gaining a slight negative charge on it. On the other hand, as the shared pair of electrons are shifted a little towards the chlorine atom, so hydrogen attains a little positive charge on it. So the molecule of the hydrogen chloride is a polar covalent molecule. Non-polar covalent bond. In the molecular structure of carbon dioxide, two oxygen atoms occupy the position on the both sides of the carbon atom. As oxygen is more electronegative than carbon, but the pull on the shared pair of electrons by one oxygen atom is cancelled out by the other oxygen atom on the opposite side. Hence, the molecule is nonpolar. In the molecular structure of methane, four hydrogen atoms surround the carbon atom on four sides. Though carbon is more electronegative than hydrogen, the pull of carbon atom on shared pair of electrons in one side is cancelled out by the opposite other bond pair. So, the shared pair of electrons are evenly distributed among the participating atoms. Hence, the bond in the molecule of the methane is a non-polar covalent bond. It is the electronegativity difference of the participating atoms which decides whether the bond will be a polar or non-polar. The properties of covalent compounds are because of the presence of weaker force of attraction among the participating atoms. The covalent compounds generally exist as gases, liquids, or soft solids. And because of this weaker force of attraction, they have low melting and boiling points. The covalent compounds are bad conductor of heat and electricity due to the absence of ions. And they do not dissolve in polar solvent like water, but get dissolved in non-polar or less polar solvents like benzene, ether, etc. Covalent compounds are less reactive as energy is needed to make or break bonds. The coordinate bonding is formed by mutual sharing of electrons, but the contribution of electron is one-sided. One of the participating atoms offer the lone pair of electrons and the other only share it. In a water molecule, the oxygen has two lone pair of electrons. Lone pair means the pair of electrons which is not participated in any bond formation. So oxygen would like to offer one of its lone pair to a hydrogen cation which has no electron at all. And as hydrogen cation has no electron at all, it would readily accept the lone pair without any of its own contribution. The oxygen offers the lone pair, it becomes the donor, and the hydrogen cation, which accepts the lone pair without its own contribution, it becomes the acceptor. But water molecule, which was neutral, would gain an extra positive charge and become an positive ion, the hydronium ion. This process of chemical bonding of atoms keep on going in the nature, which keep our nature full with substances.